what we discussed yesterday. That was on the introduction, level 1. So today, this is our lesson 2. And yesterday, what we were doing basically is to go through our units or the topics that we have. We have around 11, quite intensive. And you see you have like 9 weeks that are remaining before the exam, 9 or so weeks, that is around 2 months. So what we did was to just browse through the topics, just highlighting for us which ones are the new ones, because as you know, the syllabus changed a couple of years ago, not even more than 3 years. So this is a new syllabus. And then what we were doing is to understand the major or the areas that we need to focus on. I mean, if you can be able to get that recording, it will be also good for you to take notes on that one. So today, it's lesson number 2. Yesterday, we introduced ourselves to ICT as a field. We introduced ourselves to machines. And today, we want to look at category number 2 in terms of the computer softwares. In terms of the softwares, what I will do, as we also did with the hardwares, we will draw an illustration. That illustration is something that from a sketch you can be able to memorize. And once you memorize, it becomes easier for you, even in the future, to remember. So as we said, the hardwares are taking care of the tangible parts of a machine. And now when it comes to the softwares, they take care of the intangible parts of a machine. That is, we are not able to see them, we cannot touch, they are invisible. So softwares are divided into several categories. We have the first classification. We have what we call the system softwares. The second category is split into what we call the application softwares. And then I've checked your notes. Some of the contexts, they are talking about the 2 branches as either system in terms of the softwares and also the application. But I want to mention this. There is also another extension that we can do, and it's still part of our journey in terms of these softwares. And this is on the programming languages. So we add it as the 3rd branch in these computer softwares. Programming languages. And then what we are going to do is to understand the 3 categories that we have in terms of softwares, starting from the system software to the application software to the programming languages. Before I venture into so much details in this kind of understanding, let's crack it in a nutshell where we can understand, or what do we need to conceptualize about softwares. Because we can be using this word, softwares, we will use programs, we will use application systems, we will use the term application packages. But at the end of the day, apart from the hardwares, which are tangible, all those other instructions that are running our machines, all those applications, the things that you have in your smartphones, nowadays you call them the apps, APPS. This is a short term for an application software. So all that group, it's simply coming in to fix itself here in terms of computer softwares. Qualities include, number 1, they are invisible, you can't see them. They are intangible, you can't touch them. They have no physical appearance or presence, but we know as long as they fall in this category, they simply form a group or the set of many instructions that are used by the machine to run. Yesterday, when we illustrated on the the hardware, we said inside the CPU or the central unit, that component takes care of all the executions that a machine will undertake. That is to say, the brain of the machine. Now, this brain is run through the softwares. So, in a simple definition, we can simply say softwares, they are a set of instructions that are enabling the machine to run. They are a set of instructions that enable what? The machine to run. Major books and major contexts, they are only highlighting two types of computer softwares. That is number one, the system software, and number two, the application softwares. But I've told you to make a note that even the programming languages, they are part of the computer softwares. It's only that when we get there, people tend to think in terms of coding and all that, but either way, they form part of the computer softwares. Now, let's come to what we have here in terms of the system softwares. Let me first break down what is in that category of system softwares. So, any program, using the word program, any system software is a program or a set of instructions that is designed to operate and control majority of the machine processing. I will repeat it again. I've said system software is a group of instructions or set of instructions that have been designed to operate, control, and even they have to extend the processing capabilities of a machine. So in short, from that definition, what do we need to conceptualize? We need to understand that system softwares, they are basically instructions to run the operations of a machine. They are needed to execute every transaction, every instruction that has to be done by the machine. For example, with the CPU, our work is to key in, to input, or to give instructions to the machine. What happens when they are received by the central units? They need to be executed. For you, you are typing a document. What you are doing is just key in one after the other. But at the end of the day, it's up to the machine to give you a platform, to give you that support in terms of a software for your work to be done. All right? So in terms of machine operation, in terms of CPU, I am emphasizing on the word CPU here. In terms of the CPU functionality, we will need a major support for what we are calling the system softwares. This branch of softwares is split again into three. We have system software in terms of the operating system. This is a program, this is a software, and by far and large in your case, this is the whole of topic number 2. We are still in topic 1, okay? Then you have another branch of system software still falling under this category. We call them the utility programs. Utility programs. You can also call them utility softwares because a program, a software is one at the same time. Then we have in the machine what we call the translation programs. You can call them softwares as well. So from that category of system softwares, the ones which are tasked for their effectiveness, operation, running, execution, processing, or handling instructions for a machine, we have these three types of softwares. These are the mother names. But however, when you look at each at a particular time, you will find that we have so many examples of each category. But don't worry, we are getting to that. Then, in here, at the middle, we have the application types of computer softwares. We have the application softwares. What is an application? An application, as we normally interact with them, they are just programs designed to enhance our operations. They are programs that are designed to make our work easier. Look at that banking application you have in your mobile phone. What is it for? It's to ensure you are not going to access that bank via a physical mechanism, but at the comfort of your own area, you are able to log in, transact, log out. What is the function of that M-Pesa app that you have in your phone or in your smartphone? Is to make sure you can efficiently transact without needing a third-party assistance. So at the end of the day, those apps, the ones we are running in our devices, the smartphones, could be in computers, they are there. They are designed to enhance your efficiency as a user. As you interact with the system, you don't need to struggle. You don't need to fight with the system. The intention of technology is to make our work easier. So when it comes to these application softwares, they are designed for a purpose of enhancing users' efficiency as far as interacting with the machine or with the information systems is concerned. I've said in this category, I'll repeat once more for us to understand. When we look at system softwares, we have said they are designed to operate, control, and even to an extent, assist on the processing capabilities of the CPU. On this side, we are focusing more on the operations of the CPU because CPU is the heart of the machine. It is the brain behind every type of a computer. Without the CPU, you don't have a machine, you don't have a system, you don't have a computer. So application softwares, they enhance users' efficiency. On this side, it's all about the machine. At the center here, it's all about we as the users of systems, we as the users of technology, we as the users or the people or human input that is interacting with an information system. Yesterday, we agreed we will be using the word system as well as information systems. The application softwares are divided into two. We have application softwares that we call them in-house, right? In-house, they are also known as the inbuilt types of packages. They are also nicknamed as tailor-made types of application packages. Then we have category number 2 is what we call off-shelf packages. This branch here will satisfy or seeks to enhance users' efficiency. Efficiency means effectiveness. Efficiency means thoroughness in what you are going to do with the machine, or it ensures your work is smart, your work is neat, or it assists you, it cushions you with the resources that you need so as to have a smart interaction with the system itself. Then on each side, we have levels of programming languages. We have the first generation of programming languages, we have the second, we have the third, we have the fourth, and nowadays we are talking about the 5th generation and beyond. Now, from this illustration, in a nutshell, you can be able just to sit somewhere and just have a memory of what their computer softwares are. And then, of course, From this side, we just focus on the machine operations, effectiveness. On this side, on the middle side, we are targeting to enhance the user's efficiency. And then with the programming languages now, they have to be there so that we can have all of this. Without the programming languages, we can't have this. So the backbone of the softwares is what? The programming languages. Of course, it involves the coding and all that and all that. So all of this, we need it very well, to understand it very well, so that we are able to have a knowledge, know-how in interacting with system softwares. On that side, we need to have a thorough knowledge when it comes to the operating, to the programming languages, because again, if we have to understand the system's development life cycle, we cannot do it without getting to understand the programming part of any system. Now, let's move from this side again. I've told you definitions for each in those three branches. When it comes to operating system, that is our topic number 2. That's what we shall be able to start maybe in a couple of days, let's say next week. But operating system is a very key software or a program that is very crucial, because without this, we cannot manage the computer resources. In other contexts, the operating system is simply known as the resource manager of any system, the resource manager of any information system, because from its definition, it is designed to efficiently manage, control, and even oversee the functionality of the CPU itself. If you go back to the notes that we have for the computer hardwares, there is a point where we say the central unit is divided, the CPU is divided into 3. We have the central unit, we have the arithmetic logic unit, and then we have the primary memory. So for these 3 departments, I can call them departments, or for these 3 components to execute their operations, they will need a software that can enable instructions to be loaded into and out of the CPU. And this software, which is very key and crucial, it is what we call now the operating system. It is always present in a machine to ensure the efficiency or the execution of all the CPU operations, meaning it has to load instructions into the CPU. It has to pick out processed information and give it out to the next level in the queue of operation. It has to ensure CPU time is managed properly. It has to ensure CPU is not going idle, or it is not experiencing idle time, because it will be checking, are there enough jobs resident into the CPU? Among its many functions, we can talk of job scheduling, for instance. We can talk of time management or CPU time management. And how does it manage that time aspect? It ensures either through the clockwise or the anti-clockwise, CPU is always kept intact into operations. It is also coming in to oversee the utilization of all the resources in the same operating system. That's why we said on this side, the softwares are focusing on coordinating not only the functionality, but also the efficient utilization of what? Machine resources. And what are these machine resources, for instance? What are the resources? We have time. Time for a machine is a resource. In other words, what we are calling the CPU time is a resource. We have information, or the end results of any processed data. It's a resource. We have files as resources. So in this nature of operating system, it is also concerned with the security of the machine. It is the one which monitors how we log in and out of our system. It is the one which manages our passwords. It is the one which takes care of timings in terms of our functions. It is the one which tracks the jobs that we do. It is the one which has control over important databases like the files, the folders, etc. So in a nutshell, just to wrap on the operating system, it is there to make sure as a software it can handle the operations of the CPU, manage the CPU, manage the resources of a machine. In short, if you forget everything, just remember that the operating system is a resource manager for the machine. And then you can be able to give so many functions that will qualify it to be a resource manager. At the middle, we have the utility programs. Utility programs, these are designed there for utilization, from the word utility, utilization. What are their function, or what is their major purpose in terms of system softwares? They ensure that the user, and they ensure that our interaction with the system, we get an aiding facility, or they ensure as we interact with the machines, we are always assisted, served with systems, or getting a facility that can make sure that not only security, but also the key functions of a system have been achieved. From the word utility, we advance to the word utilization. That is to say, at the end of the day, all the users or the machines, let's talk about the machines, all the machines will need to have utility features. At least through these utility features, we are able now to have a thorough interaction with the system, because inside that program, inside the machine, we have resources. And these resources, for them to be properly used by the clients or the intended users, they have to be properly utilized. So these are programs or a group of softwares. Their work is to ensure there is proper coordination on how we are utilizing. In other words, we can nickname them and call them support programs. Support programs meaning they give us an assistance. Their work is to manage users' computer system interaction. The word is users' computer system interaction. In a nutshell, here we have a lot of them. We can talk about print utilities. They just ensure you as a user, you are able to get a printout of what you have instructed the machine to do for you. We also have merge utilities, just to ensure in a click of a button, you are able to achieve a function that would have taken you more and more time in compiling documents together. We also have things or likes of the antivirus utilities, just to ensure the security of the system is observed all the time, or the antivirus programs that we have to run in our systems for the purposes of security, etc. Then we have translation programs, translation. The term, we can also call it translating, meaning they convert instruction in one state to another state. They convert instructions from one form to a different format. That is to say, we need them, or they are needed by the system or the machines to be able to capture information that is in different formats and being able to translate it into a different or to the agreeable format. The likes here, we have things to do with compilers. We have compilers, we have the assemblers, etc. At this point, we are looking at languages. Languages which are now our programming languages in this scenario. you realize that what we understand, we human beings, at the time that we started interacting with machines, we could not speak the same language. We could not speak English to the machine and it will understand. Forget about the 5th generation where we are today. Things are a bit advanced. Earlier on, we had stages of development whereby the only way to interact with a machine was to feed instructions in our own nature. That is what we are, the source. We call it the source code. C-O-D-E, source code. So these languages, they needed, or at some point, they need to be picked up by softwares, by translation mechanism, which can now pick it from my own human input and convert it into a machine input or into what a machine can understand for it to execute, for it to manipulate or to process. So that is where we add or we have the translation programs. Then let's come to the second side of the computer software. These are application programs. Their work, we have said, is to enhance the user's efficiency. At this point, they narrow down to either general needs of a user or what we can say specific needs of a user. When we look at general needs, these are the universal needs, the one which seems to be common among many users of an information system. Then it says specific needs, these are personalized. They are personal-based type of needs that different users are, and they vary. We have programs that are known as in-house. In-house means a program that you have developed for yourself. A program, a software that you have customized to suit your own needs. If today I would walk to a shop and I want a dress, for instance, I will have to take my own measurements, for instance. I will have to have the size that fits only myself. That is a tailor-made sort of a garment. So if a user is going to customize a software that will only be unique to them, that is inbuilt type of application packages. And we would ask ourselves this question: why would a user customize their own software? Why would you, this is Ida, why would you customize your own program? It's because you are unique with your needs. That is number one. You have unique specifications. You have unique requirements. You have, or you, at some point you will, or you have maybe interacted with institutions, and you find that they have their own tailor-made programs that they are working with. What do you think pushes the management to adopt such a mechanism or to make such a move? It is due to some reasons, like they have unique needs. So their requirements are not universal. All right. Number two, people also or users customize these programs because they want to be more secure. A program that is tailor-made is more secure to you because you understand it better than anyone else. Again, there's this sense for which is anything that is in the public domain remains open, but anything that is private, you can close it. So if you customize your own program, you can be able to close, and it's yours and yours alone. Another reason people why organizations would customize or go for tailor-made programs is instances where they have their capital in terms of the human power or the manpower to undertake such an exercise. If you have a sufficient IT department, for example, or personnel, it will be their work to undertake the project, customize the programs, and deliver them to the organization for use, because you are paying them at the end of the day, you have them. Another reason, apart from having the manpower, you customize it when you want or when you are sure that the risk that you can take is within your reach or it's within your budget. That is to say, you have the financial capability to meet the cost of developing a program, because it's a involving as well as an expensive process to develop a program till you deliver it. Think of the bigger institutions, like the way you have a very important function, department or ministry, like where we have IEBC. That's a very crucial unit in Kenya. So if they customize their own softwares, if they customize their own processes, it means they have the capital, they have the manpower to undertake such bigger projects. Then on the other end, if you can't customize, you can just procure direct from the market. What is available in the market is what we are calling the off-shelf packages. The word shelf tells you, like the way we have racks and shelves in the supermarkets or in the bigger stores, you will have to pick it from that store and buy it. So the chances of you buying this program, it means you are going for a general software, because most of the off-shelf packages, they are general programs. They are programs that are made for the public. They are universal in nature. They serve universal needs, like the way you used to have those universal chargers, which can charge as many devices as possible. That is the same case with the off-shelf programs. What are the circumstances? Already I've tackled for you 2 questions from the past papers. I've tackled for you a question on this one, why an operating system is known as the resource manager. The second one, circumstances that may force institutions or organizations to go for tailor-made programs or in-house programs. The third one are the circumstances when institutions or enterprises can adopt or can go for the off-shelf packages. Number one, why do we rush to the market to buy something and then utilize it? It's because we are in a hurry. So that means there is urgency of the situation. There is urgency of the problem at hand. We do not have time to develop, so we need a ready-made kind of a program. That means we are also rushing to buy from the market because our needs or our requirements are universal. They can be widely applicable to the so many public programs that are available. Another situation why we are buying is because we cannot afford. Buying is cheaper than developing. We cannot afford the cost to develop. That is why we have to buy. Another reason why we are buying to save ourselves time. And then, of course, the number 4 concern of a user going for the ready-made programs is because they are afraid of taking the development risk, because these off-shelf packages, they are developed by experts in the market. So they are less, or they are free from errors, or they have minimal errors. For a software to be released out there in the market, it must be thoroughly developed and tested. So the chances of error here, they are minimal, okay? And then again, looking at thoroughness, then what are we targeting? High efficiency. That is another concern here. We are looking for highly efficient softwares. And then, of course, we know if it is in the public domain, most of the users are conversant with that program. Anything that is public, like the same way we have those public platforms. Who trains you? Nobody. You just interact with it within a very short time. You can find your way out. That means another circumstance, if we are going for the ready-made programs, then we are likely, or we are targeting less time in training. Less time in training, because this type of packages, most of them, Since they are meant for the general packages, they are also accompanied with what we call a user guide, or we also have a user manual, etc. And then, of course, as we have said, they are developed by experts. Who is an expert? It is an individual who has skills, specific skills, or possesses knowledge in a certain field, and not just knowledge, sufficient knowledge in a certain field. So whenever there are problems, whenever we have challenges with this kind of softwares, it means it is easier to get an assistance. It is easier to troubleshoot them. They are easier also to work with. They are more user-friendly than this other type, or than what we are customizing, than what we are going to develop in our own organizations, in our own institutions. That is not the case here. Then on the third side, we have now the application programs. Sorry, the programming languages. Programming languages. Programming languages, now this is another bracket. I've told you programming takes care of the coding part of the instruction. If you are drafting a letter, what will you do? You will type. Okay? If you are drafting a Word document, you will type. How will you type it? You can decide to either use languages like English. Kenya is a Swahili-speaking nation. You can also use Swahili, or maybe you type it in your own native language. For you, as a human being, that is what you understand. Now, when it comes to machines, there is the language of the machine, and this is it. Now, these generations, we are almost down here. We are trying to develop better and advanced programs as much as possible. So what we'll do, we'll just browse the 5 categories, because I've seen some cases here and there when they try to tease you on how the languages evolved. The first generation of programming languages, it was purely known as the machine language. Machine language means it was a very low-level kind of a programming language. These two are known as the low level, and this here, we call them the high level. What I've seen happening in our past papers or in question papers, they are simply not venturing into either first, second, third, like that. They will only ask you about the low level, which is generation 1 and 2. That is low level. And they will also tease you on the high level. High level comprises of third, the fourth, and the fifth. So what we can all understand, or we need to understand, is what it takes to be a language under the low level, and what it is about languages in the higher level. So let's go with first and the second generation. With the first generation, I've told you it was known as the machine language. Machine language means it was developed with orientation, or its internal representation of data and instructions, it was only machine-based. It was a language that the machine could only understand by itself. And what is the language of the machine? Whether it is digital, whether it is analog, the language of the machine is in digits. Digits that are selected. There are only 2 digits that are being applicable when it comes to machine language. That is the 0 and the 1. 0, 1. Those are the 2 digits that comprised or were used to develop the first generation of programming languages. In that point, or at that particular instance in time, working with zeros and ones was cumbersome. It was tiresome. It was not easier to sit down and compose a programming language in terms of zeros and ones. As far as the machine could understand it and could execute it without a translator. But for the human beings who composed those programming languages, it was tedious exercise. Again, due to their cumbersome nature, they were slow in execution. So the machines used to be slow in terms of the processing speed. That's why we normally say the very first generation of computers, they were very slow. It would take hours to read a sentence. That is how slow they were because of the cumbersome nature of those programming languages. So as that was discovered, there was need now to improve because down there things were tough. So they went to the second generation. The second generation was termed or was defined as assembly languages that came up to replace the machine language. However, they were still considered to be low level. They were still cumbersome somehow. But one slight improvement, they were now more friendly to a human being. But they will need translators like the assemblers to be converted into machine language, again for the machine to understand. Remember I told you, machine has its own language that it understands. So as that generation also was being perfected and all that, they realized the execution, even though it could move a single statement at a time, it was still not at the speed that they desired. So they went on, and these low-level generations were now replaced with the high-level generations of programming languages, starting with the third generation. Third generation was a more developed type of programming language or coding. It used what we call procedural language. Remember the first one we said it was assembly language. Sorry, it was machine-oriented language. The second one we've said it was assembly, kind of a single statement being executed at a time. Then the third one, the third level now, these were procedural types of programming languages. What does it mean to talk about a procedural language? Procedural language, in its nature, it required the users or the programmers to determine or to write a procedure for the machine to follow in executing an instruction. And I would ask you, was that, or is that the experience we have with the systems? Of course, no. For us, we interact with the systems at a level where we are just feeding them instructions. They do the job for us, we get the feedback. Unlike now, in that generation, the third one, the programs were to be written or they were to be coded in terms of procedural statements, procedural language, which by far and large it was closely to natural language, but it was not exact natural language. So what does it mean at that point? The procedures were targeting, or they were more oriented on the results. And because of that, it is not our work to provide results for the machine. It is the opposite. It is the machine to provide results for us. So they still saw there was a challenge, there was a need to improve those types of third generation programming languages. So what happened? We moved to the fourth generation types of programming languages. And at that level, they were non-procedural. they were non-procedural programming languages. That is to say, a programmer didn't need to use or to specify the procedure of execution for the machine. Okay? So this category, the non-procedural machines, they could allow, or the languages used to allow, or are allowing users to specify the desired results without having to give it a detailed procedure. I'll repeat again. The fourth generation type of programming languages were non-procedural. That means a user of an information system was allowed, or they are allowed to specify the results without having to give the machine the specific procedures to follow to achieve that result. What are we doing nowadays? We command the machine. We ask the machine for some questions. We give the machine instructions in form of various requirements, all right? We just feed the machine with instructions. You tell the machine, kindly get for me 2 times 2, okay? You don't specify the results for the machine to activate or to act on your behalf. What you do is you query. And then when you are querying, it gives you an answer. You ask, you command, it gives you feedback without you having to give it the procedure to follow. So that is the time now a lot of improvements also in databases came into existence. We had more developed languages, like the way we have querying sort of languages that are normally there to assist you in querying for information from the machine. So at that particular point, we can say databases were in use. A lot of procedures were abandoned because now the system was non-procedural. You are only required to command it, or you ask for results without giving it a procedure. And then things now were more advanced because at that point, we started interacting with machines using English or using statements that are formatted in form of the same English that we know. And then, due to advancement, because we say one of the qualities of ICT or the characteristics of ICT is future-oriented, meaning we are not satisfied with the ICT at the moment, not tomorrow, not the day after tomorrow, but we are looking at it from a future perspective. We have to further advance to what we have nowadays as the 50 types of generation in terms of these programming languages. We are also nicknaming them as the natural programming languages. And you can even practice it now. You just take your smartphone and type anything in any other language apart from English. You know, English is close to a universal or to a widely applicable language. You can type anything in Swahili, it will still accept. Even the machines, especially within the Eastern Central Africa region, where Swahili is mostly used, they have that in part of their languages available. You can use that smartphone or that laptop and you type in your own native language. That's why we are saying with the 5th generation of programming languages, we are having them as natural programming languages. Languages that are next to a human being. The target here, or the concept of that 5th generation of advancing computer softwares is to come up with human systems. When I talk about human systems, we are looking at an evolution phase whereby we have machines that are functioning like a normal human being. We have machines that can imitate human behavior. We have machines that are so advanced that through the artificial intelligence concept, they can execute duties, they can execute tasks close to a human being. And that's where you have the artificial intelligence developments and related fields, because the programming languages there are so close to a natural language that a human being is using. They can sense environment within themselves the way a human being will do. If you lock yourself into a room, and then let's assume it's during night, maybe you are scared, and then the moment a person will tap your door, what will you feel, or what will be the experience? You will be alert. Or some of your nerves or your body parts or your sensory system will start detecting maybe there is a person or there is what? There is danger. That is human behavior. You are alert. Some parts of your body can respond to the environment. So what happens? You are somehow activated to act in a certain way. That same concept is being borrowed by the systems to develop machines, to develop technology whereby a computer system can detect its own environment, okay? When it is cold, what happens? We human beings will cover ourselves because we are looking for warmth. The same way we have systems that can sense temperature, humidity levels, can sense anything in the environment. That is the world we have today. Artificial intelligence and its related fields, developing systems that can mimic human behavior, that can function as a human being in terms of its execution of operations. Now, let's look at an overall picture in terms of considerations, because I know applicability is very key, is very crucial as far as ICT is concerned. We say, however, we are dealing with a theory paper that we need to have hands-on experience in terms of how we are applying or how we are interacting with technology. In that sense, we need to equip ourselves with knowledge at a level of applicability. Most of this has to come in theory, but we also need to understand the concept from a point whereby it is close to application. Now, in a nutshell, through what we've discovered, let's assume now we are on a practical basis where we want to acquire an information system software. We need to acquire softwares. We have considerations to make. We have circumstances which can force us in selecting. So let's look at the qualities, or what we can say they are the desirable characteristics of this as a group, characteristics when we are choosing a software. If you get a question, what are the factors to consider when you are selecting a software? What would you say? Or what would be the input there? Desirable features of softwares, desirable features of any type of software, from where we have listed the operating system to the last one in terms of the operating, in terms of the programming languages. Let's list them very fast. Number one, we have to juggle in terms of finances. You have to consider the cost. In any selection of a software, look at the costs. We have two types of costs. We have the buying cost or the purchasing cost, and then we have the maintenance costs. Because as you progress with using the technology, you have to maintain it. You have to keep on checking and reviewing its performance. So all that forms part of the cost in terms of the system, in terms of the software. So you have to look and consider costs. Costs can force you to either Just buy directly from the market, or it can force you to develop, depending on what you want, depending on how financial, in terms of your financial stamina, how well are you? So consider the cost, looking at the buying maintenance cost. If you are going for any choice, it should be cost effective. So the cost factor number one, it should be cost effective. That is point number one. Number two, in terms of a software, we also need to consider what are the available features. Features available. I'm only noting the keyword. Then we do like this, meaning we have to add more English there. Features available. The features are from the many consideration of that software. If you look at the capability, not the capability as per se, but the program inclusion as a package, the features will dictate for you whether it is desirable or not. Again, the features should also align with your own unique or with your own general requirements. Another consideration, another factor, another characteristic is the software performance level. How efficient is your software in terms of performance? How effective is it able to function without downtimes or without failures? Performance. Is it thorough? Is it high? Is it low? Is it moderate? Performance. Many of the times you will go to maybe public services and places, you find that they are slow in serving their clients. That means if the problem is not only the server, but also the software that they are using, at some point, it could be slow in performance. It could be affected by so many other factors which forces its performance to slow. Okay? Another desirable feature of this software, we have the instant reconsideration in terms of the portability. Portability means it can be moved. Portability means it's easier to carry from one place to the other. But in this scenario, we are looking at software portability in relationship to how can we be able to apply the programs from different machines or into different machines. A software that is portable, it means you can copy it from one machine to the other. But we can't use the word copying. Copying will sound like piracy. But we don't want to go for that. Copying means if you buy one license, or portability means if you have one license, can you be able to duplicate it in various machines? So today I have this software package as one license. Is it allowing me to apply it on various computers or several computers at a go? Portability, the convenience it offers you as a user to duplicate it or to move it from one machine to the other. For example, if I bought a software and installed it in this machine, and then with time, I will need now to change from this design of a CPU, or maybe from this design of a workstation to a different one. Will it allow me to copy everything or to move everything from this workstation to a different workstation? That is what we are looking at, portability. The fact that it can allow you to move it from one place to the other. Look at this other one, number 5, very interesting. Compatibility. Compatibility of softwares. Compatibility. Compatible means if something is compatible, number 1, it should have qualities like comfort, conform, Not only comfort, but conformity. That is the key word to understand. So a software should be compatible in nature. It should conform with the kind of work that you are doing. It's like we are talking about it must agree. That is the word. It must agree to the nature of work you are doing. If you are operating a customer care center, the kind of a system or a software you go for should conform to the kind of tasks, to the kind of operations that you are going to subject it to. Because in a customer care center, we expect a lot of calls, we expect a lot of emails, etc. So that software or those softwares you are getting must conform to the nature of work that is being undertaken. And another key and second compatibility. It must also come together and work with the other existing softwares. I've used the word come together and work with other existing softwares within your system. If today I'm going to the market to get an additional program to install in this machine, if I will get an additional software to this machine, it means once for compatibility to be a quality that I chose, or for that software to meet the requirements of compatibility, it means once it has been installed, it should agree to work together with other existing softwares. I've said it must agree to work together because there are instances that when you buy or maybe when you install a new application, it starts misbehaving by blocking others. You've seen programs that behave like that. Once it is running, no other program can run. Or once it is installed, it deactivates other existing softwares in that machine. That shouldn't be the case. Any desirable software should be compatible in nature. It should be compatible in nature. Another quality, number 6, it must be user-friendly. Because as the users, we are desiring to have a free or a less tiresome interaction with machines. That means any software that you are going to take or to install in your machines should be user-friendly. It should be easy to interact with from the user's point of view. It should be easy to work with from the user's point of interaction, not a software that will bring in complexity into your system such that your users cannot crack the procedures or they cannot understand on how to navigate. User-friendly is a very important feature when we are looking at softwares as well as also the hardware, because we have to fix them and all that. User-friendly, convenience for you between the software and who? And the users. Number 7, we have reliability. Reliable. If something is reliable, we know that it won't fail you. It won't let you down. So the same way, we need these softwares to be reliable. Reliable means it should perform its functions up to optimality without letting the user or the organization miss out in anything. Reliability means, for example, if this forum is supported by a certain application. So for that software, for that program which is running, it should always, whenever I'm here, it should be ready to function. Not that we are in session and then it is off. Forget about other instances where like the network will be low or slow, or maybe there will be no power. We are looking at the program itself. We don't want to use the word availability because availing is like provisioning, but we are looking at reliability in the sense that we need it. I need the software to be there whenever I'm ready to use it, not the other way around. I should be the one as a user to be available. It is the software now to be available for me to use it, okay? It should be readily available for my execution of tasks, etc. Number 8, we have flexibility. Flexibility and this quality sometimes will collide with portability. But portability, we want to understand it in the nature that we are looking at the movement. Reliability, flexibility, we are looking at how we can flex the usage of that particular software. Flexibility, we are looking at an all-round package which can not give you multiple tasks, but you can apply it in other scenarios. Flexibility as a quality ensures that the software selected is put into various uses, or it can be put into many uses. For example, when you have a spreadsheet, like a program, or when you are looking at Excel sheets. Excel sheets, we can look them as a tool that enables you to do calculations, okay? Whenever we are working with data that has mathematics, we tend to run for Excel sheets. This is because they are built with the capability to do calculations. But look at other functions aside or apart from the calculations. That software or that Excel sheet can tackle other functions, like it can format your data, not only in those calculations, but put them or transform them into any other statistical report that you need. Within that particular worksheet, you have multiple of functions that you can undertake just within one package. That is the aspect we are looking into in terms of flexibility. In terms of flexibility. How many points do we have? We have around 8 points. Let's add 9 and the 10 at our own free time. You can add 2 at least to accompany mwalimu. Let's look at another understanding where we have the segregation of machines. Classification. How do we classify computers? Now we've understood what we have in terms of not handouts, but in terms of hardwares, we have the softwares. We need to understand the classification of machines. Classification of machines. We have various classes. We can classify machine, number 1, based on their purpose. Classification number 1, we have by purpose. Classification number 2, we have by size, in terms of their sizes. When we look at purpose, we have general purpose machines, and we have the specific. From the word general, it means it is widely applicable for many functions. For instance, your own office machine, you allow it to do several functions. That is a general type of machines. Specific means it narrows down to serve a certain or just a single function. If you look at machines that are used for maintaining patients in HDU, You cannot go in there and log in and subject it to office work because it is specific to undertake patient diagnosis only. By size, sometimes they call it classification by size, power, etc. By size, it means either big, moderate, or very small types of machines. We have the very first size and power. We have the supercomputers, very big machines, powerful, very high in terms of speed, etc. We have the supercomputers. We have the mainframe computers, moderately. We have the mini computers. We have the microcomputers. Then we have the portable computers. In that category, the highest are the more powerful, bigger in size, very fast in speed, efficiency in effectiveness, etc. The second category is moderate, is just somehow inferior to the first category. The third one lies in between the second and the fourth one. And then, of course, when we are going to the micro, those are the smallest devices we have in the market. And then, of course, we have the portable gadgets, starting with the mobile phones, calculators, those small things that you can put in your pocket, and then you are able to just move around with them. Classification by power, size, and also by the nature of the purpose. Next, let's look at the applicability of machines. All across industries, we are able to apply computers. The world today, we are running on machines. So let's just list out today. These are very easy things to just even conceptualize and remember. Application areas, computer application areas. There are so many. There are so many, starting with what we are having now. It is an application area in terms of education. You can quote education and training at the same time. That area is largely and widely utilizing machines. Look at what came after COVID. People started to embrace technology because we realized we can still be operational without moving around. So that is one application area where we widely use computers in virtual trainings or in distance training, like the way we are doing now. We also have machines in communication. That is another application area, communication, where in particular, starting with our mobile devices, that is for communication. Coming to the bigger perspective of the industry, where now we are looking at the telecommunication industry, where now we are widely relying on the sector to support us in terms of communication. We also have retailing application of computers. Retailing, it's all about selling. Retail outlets, whereby machines are taking instructions, orders, executing the process to the final point. Retailing now carries the aspect of also where we are looking at electronic business, because now with the technology we are bridging many of the physical exercises or activities that we are doing in business. We also have machines or computers in home applications. Nowadays, we have the latest products of technology, what we are calling the smart homes, digital homes, whereby everything or majority of your appliances are run by technology itself, starting from that washing machine you have, going to that fridge, look at that microwave, look at those CCTVs in your compound, Look at the solar on whatever heating system, the lighting system in your house. We have scenarios where now technology is running those machines, and that is an home appliance as far as computers are concerned. We have commercial applications whereby we are going to commercialize and we are going to manage the manufacturing and production procedures in various or all across the industries. We can simply talk about manufacturing and production applications. We look at management, MIS itself, Management Information System. We are applying machines to manage information and materials. Application in MIS, management of information and materials. Look at healthcare applications, healthcare and related systems applications, healthcare. Where are we using computers? We are using machines to manage patients. We are using computers to do diagnosis. We are using computers to monitor patients. We also even have advanced to a level where you have a kind of, you can get even applications that can track what particular diagnosis you usually take with your doctors. That is machines. Let's look at scientific applications, science and research. Science and research. With the developed world, they keep on exploring. They keep on exploring the space. They keep exploring the underworld. They keep exploring all sorts of, things in the nature. How are they doing this? They are simply using computers for the purpose of discoveries, for the purpose of exploration. Let's look at another application, banking sectors, banking applications. We moved to a point where we were interacting with physical cashiers, or we were used to traditional banking methods. Nowadays, because of computers, we are doing what we are calling the modern types of banking, where you can even have all your bank accounts in one smaller device like a smartphone. Look at entertainment, application of computers in entertainment. We are using machines to entertain ourselves, like the way we have various softwares, applications that are running entertaining materials. With a micro or with a portable computer like a smartphone, you can be able to tune in, watch news, listen to music, do your own social stuff, etc. That is all supported by machines in form of computers. Very short and key to the point, application areas for computers. We will need the same knowledge when we will be looking at another advanced level of e-commerce, because you will borrow that knowledge and tell us where we are now in this era of e-commerce, how we are now fully utilizing the machines. Very quickly, in the next couple of few minutes before we end the lesson, I want us to have an understanding of the ICT hierarchy and its personnel. I don't really think we need to waste a lot of time in that or spend more time in terms of that. I will only have to mention. Mentioning is all about understanding where we are. Of course, any department that is under ICT will start with a super or a senior person. This senior person can be someone like a manager, ICT manager. Then in terms of that ICT manager, we will need some staff. This staff, their work is to manage the department together with the ICT manager. Most of the time, they are just tasked with various activities based on experience, based on qualification. I'm not saying these are the just main key, personnel we can find, but these are very key. We cannot finish what we are discussing without coming across a system analyst. We are not finishing it without understanding a programmer. Who is a programmer? We can't do without a system administrator. So in this whole unit, in this category of understanding the personnel, the only practical or the only sound information you need to have is just to understand their levels of qualification and also some of the likely duties, roles, assignments that they undertake. The manager, of course, is the overall boss. He has to oversee the department like any other head of a department. He does duties closely related to those of any other head of department as long as they are ICT related. Duties like supervising all the workers in ICT docket. Recruiting, he's in charge of recruiting with the other HR. He's in charge of hiring the best candidates in ICT. He's also in charge of firing. They can fire you. Is in charge of now taking over in advising the management or in advising the organization when it comes to ICT projects. They cannot undertake them without a word from that manager in terms of that docket. So he advises the management on ICT innovations, inventions, implementations. He is also in charge of taking care of ICT compliance and advising the organization. The other day, there was a company which was sued or maybe is facing, legal sort of charges for not disclosing some facts about their data. So where is that headache going to? It's going to the person in charge of technology in that particular company. Under this person, we have other members. We have other part of the group, like the system analysts. This one we need to emphasize because when we be going through SDLC, we will be mentioning this thing. System analyst, this is a computer science qualified guy or is a scientist in the field of computers that processes sound knowledge because they are very key and their work is very crucial. Their duties will range from studying information systems and developing them together with other people like now the programmers. These are the people in charge of developing the program codes or the instructions. Then we have the system administrator, the admins. These are tasks in as far as accessibility and security of the system is concerned. They administer the resources of the system. They take care of the users as well as they take care of the resources of that particular system. And then down here, we can add as many users or as many personnel as possible, starting with the network designers. Their work is just to design networks. We have the web developers, those who come up and design and develop the web pages. We have other crucial employees. We can have the librarians in charge of databases. We can have the trainees in charge of just, or maybe in study, they are being introduced to the field of ICT. We also have the technicians, very important in terms of support, in terms of assisting the users with general running and installation of machines. We also have the computer clerks, those who get our files ready, those who take care of our information centers, etc. These are not the only people we have. You can come across people like computer engineers. Their work is to specialized. A computer engineer possesses key knowledge in either hardware specialization. If he's an engineer in sorting the hardware, they have to do it and you will like their work. You can also get computer engineers, those are specialists in the softwares. They can only, they not only design the devices, but when they also design, they recommend the best softwares to run on those particular type of devices. They can also go an extra mile to design, advise, and even develop a software for it, because this is a more of a qualified, is an expert in short. Then we have others, like the administration level, we can have different types of administrators. We can have a system administrator, we can have a database administrator. Administration focuses on the now protection, or maybe administering and overseeing the utilization of resources. When you look at a person like a database administrator, they ensure that in your organization or within that functionality of a machine, we have databases. We have, we are able to get our system information kept at a centralized location, or maybe if it's a decentralized, well and good. Apart from this, you can come up with any other types of personnel, and the good thing is to understand their duties, their roles, etc. Because today we target to finish our discussion with introducing ourselves to systems. Let's tackle the role of information centers. And then, of course, I will leave you to think and come up with suggestions on the impacts of ICT. The role of, ICT information centers, I will say, these are like the customer support centers, ICT information centers. They are the same as the customer care support departments. For instance, if you have ever visited any customer care department, it's because you had a concern to be addressed. So the same way with technology, we have information centers to take care of the following activities or some of their duties. So these are the roles of ICT information centers. They are tasked with training of users. They train us on how to utilize technology, how to utilize the hardwares, the softwares, etc. Very simple, training users. Time to time, we consult them on applicabilities, on different specialities. So they are tasked, or they have a role in consultation, just serving or answering to the end users. They also assist users in problem solving. That is another role they play, problem solving. That is to say, they will assist you. When you are stuck, they give you solution, or they give you a suggestion, okay? They also give us what we call product support. Product support, that means when new products are being launched, they will give us guidelines. If they are launching a different type of technology, for example, if now Zoom is advancing to a different technology, what will happen, the ICT customer centers will take care of that that concern to orient the user. So they are there to ensure we are supported with product information, product related queries. They also administer ICT resources. So they have a role in administration of ICT and its related resources. They assist the growing organization with staffing or with staffs. So you can outsource ICT support from those information centers until you are able to hire your own internal ICT personnel. They give you the customer support in form of outsourced personnel. Under cloud computing, they are very supportive. They give users hardware support. For example, when it comes to cloud computing, nowadays we are given free services, whereby we can access the cloud as an infrastructure. We can get services like platforms. We are also given now softwares. Those are some of the roles ICT can play within, those are the functions of the customer care support under ICT. I've given you 7, make them 9. You add 3 roles. 3 roles under the ICT information centers. Let's look at the impact. Let's summarize everything now. We are concluding. Let's summarize the impact of ICT in business. If we were to get this question, I always emphasize, if it is silent, then you are likely or you are supposed to explore both positive as well as the negative impacts of ICT. In businesses and the evolution rate at which ICT is moving, we can really say there is huge impact. Some of them, they are positive. There are others that are negative. And we are not saying they are disadvantageous. They are only impacts that turned out to be negative. For example, let's look at the positive ones. Number 1, positively, how has ICT impacted the business environments? To start with, I can talk of opening the market for all the participants. Through ICT, we've we've had the capability of wide market availability. This is because the flexibility of technology allows you to approach more and more in terms of the business, in terms of the modern business. So it opened the markets. It increased accessibility of resources. ICT increased accessibility of resources. Resources like information. All the businesses need information, whether it is for competition or not for competition. We need to have both internal as well as external information. Also, ICT has improved the efficient distribution of goods and services. Efficient distribution of goods and services. Look at what is happening with digital commerce, where we can either conduct it as partial or a full or a pure electronic commerce, leading to higher efficiencies in terms of distribution and accessibility of services. Another one, we can talk about the global reach. Global reach can tie with the opening up of markets. Global reach. We are at an era where we are now experiencing digital global village, whereby all of us, we are able to access each other in terms of business, in terms of transactions. Another positive impact, ICT to some point created more and more business opportunities, because industries or organizations realized better ways of doing business. And by doing so, they were able to do better, increase their portfolio. In that increased portfolio, we also realized we were able to employ more. So employment opportunities grew with the way the businesses were growing also. We also have ICT impact in terms of creating learning opportunities and learning platforms. For instance, anyone who has missed this this session in terms of attendance, what will they do? They will have a backup in terms of the recording and all that. That is technology. So it has increased the provisioning of learning platforms, whether in terms of classwork, whether in education, whether in social life, we are learning. Nowadays, we have platforms which just support you with tutorials, platforms which support you with, step-by-step procedures on how to tackle some things on your own. Let's look at the negative ones. We can also add there in terms of business how ICT can help you to cut on costs, save on time, among many other reasons. Impact of ICT in business, negative impacts. Negative impact. ICT is expensive. It is expensive to acquire, it is expensive to maintain. ICT is expensive to acquire, it is expensive to maintain. Number two, ICT is disadvantageous because you have to support it with power. So where there is no power or electricity availability, ICT will not be experienced in that kind of business setup. Number three, ICT, we can say to some extent, it created an opportunity for layoffs, or maybe it led to downsizing when it comes to human power in business. Some were downsizing while ICT was being embraced. Like the way we used to have banks and the tellers. Many people were replaced by technology in that sector. And that is a disadvantage. It's a negative impact to that particular kind of a business because they had to downsize the workers. In as much as the banks were enjoying their benefits, other benefits or other positive impacts that came with the technology, to the workers now it was a pinch. It was a punch at the back because people were being replaced by smart machines. And then of course, ICT consumes internet or moves or utilizes internet in most of the areas. What are major impacts or major negative impacts of internet? We have cases of virus and other malicious activities taking place. I've just browsed in a nutshell the impacts. I want you to add more and more in terms of the impacts. And then by doing so, you can see really time is not on our side. We have to stop at that point, marking the end of our lesson number 2, being introduction to computers or introduction to information systems, generally introduction to ICT. We have like 4 or 5 areas to watch. That is on there. Computer hardwares, computer softwares. We have to watch on ICT personnel or the hierarchy itself. We will have to watch on the roles of, ICT information centers. And then of course, we have to be aware of the general impacts of ICT in business. If you are good in those, or if you can be able to crack down everything, because of course, after here, we will just get the soft copy notes, just go through them, browse, and then let's prepare now to meet and start our topic number 2. That will be on next Friday, 7 p.m. We shall start the operating system.